Hey, good morning, Algebra 2. If you're on here, God bless you. It means that you need some help, so I'm going to run through these, and you're just going to scroll right to the ones that you need. So let's get started. Okay, so the first one, evaluate. This goes way, way back. You're just plugging the number into the place and solving the problem. It's an order of operations question. So the 9, for this case, you plug in the 9. You do what's in the parentheses first, and multiplication and division come before addition and subtraction. And then you finish off by just completely solving it. I don't think we have to do much here. I don't remember there being much problem with this. But once again, you plug in the number, parentheses, in the parentheses first, then look for exponents, none of those, multiplication and division, and then addition and subtraction in order from left to right. Okay, solving equations. Now, once again, you've been doing this for a long time. These probably from pre-algebra, and then these Algebra 1 type of questions. And you know that the key to doing these is always to do the same thing to both sides of the equation. So here, adding 8, then dividing by 9. Here, distributing first, then moving the variables to the same side by subtracting 4x from both sides, then adding the 9 to both sides and dividing by 4. Here, the thing that you have to do, don't forget, distribute first, then bring everything to one side by subtracting the 3x, then we subtract the 5 from both sides, then divide by 4 and simplify. Don't forget to reduce your fractions, important. Then over here, once again, distribute. I've subtracted the 4x from both sides. I've subtracted the 42 from both sides. Divide by 3, get negative 13. And so same thing to both sides, as you know. The key on the absolute value problems is to remember that there's really two answers to each one of them. So you have to split it into two parts. Okay, it equals the positive or the negative version. The positive or the negative version. And then it's a matter of solving like you know how to do, treat them as completely individual problems, and you get the two answers that make sense for that. Solving systems of equations can be done several different ways. It can be done by substitution, elimination, a calculator, finding the intersection, various different ways. But when you have both of them solved for the same variable like that, it's just easiest to say, okay, well, 7x plus 10, substitute that in there for the y, solve for x. But don't forget, when you have a system, once you have your x, you need to plug it into one of the equations. Doesn't matter which one, because remember, the solution needs to work in both. And you get the y that goes with it, and your answer is an ordered pair. So please make sure that if you expressed an answer like this, that you make it as an ordered pair. All right, this next one, solving the system of equations using a matrix. This one we'll camp out a little bit longer on. You have two ways of handling it. You can either use it in a calculator and do a matrix, okay, and then enter it and calculate it. So let's review that process. Okay, let's review the process. It says calculator, second x inverse, second x inverse, because that's where the matrix lives, matrx. We want to edit the matrix, so we need to put that in. We need to enter your matrix. Now remember, this is review, so I'm going to go a little faster than I would for normal, but okay, just so that you see it one more time. And then you put all your numbers in. Okay, I'm going to put in 2, and I'm going to put in an 8 and a -1. Oh, now that would be the blue negative. We don't want the blue negative. We want this negative right down here, or we will get an answer, -1, and then 19. And then we go to the next row and we put in our 5, our -3, not this one. If you get an error, that's probably what you did. 1 and 35. Okay, and then we'll put in 4 and -1 and 1 and 30. Okay, so we're just going to double check our numbers here, make sure that we've got them in right. The mistake that was generally made, I think, is people just accidentally putting them in the calculator wrong. Because once you have that, we go back out to the main, let's quit, and we need to go into matrix again, which is second x inverse, and you go to the math option. Okay, and for the math option, if you wanted to go ahead and do all of the solving for you, you go down to where it says RREF, not ref, but RREF. You should remember this. You want to choose the matrix that you put it in, like there we use matrix A. So we're going to choose the matrix A. So we have to go into second matrix again, pick A, and hit enter. And there it is. So the x equals 7, y equals 1, and z equals 3. So that's the complete calculator method. Now, if you do not particularly like to use the calculator and you like to solve them out, I'll take a minute here to go through this. Okay, our main process is going to be to eliminate the z's here. So we're going to do this hopefully carefully. So I'm recording this live, so we'll see how this goes. 8y minus z equals 19. And 5x minus 3y plus z equals 35. Okay, and we're going to add up those because the z's will cancel out like that. So I have 7x plus 5y equals 54. And then since this is a negative z, this is a positive z, I'm going to use that same top equation and put it together with the bottom equation so I can eliminate z's again. Okay, and we'll put these together. 6x plus 7y equals 49, and that's the heart of the beginning. In the interest of time, I'm just going to put you on pause for a second. Okay, so I did jump ahead a little bit so that you wouldn't have to waste time watching me write all this out. But if we take this equation that you got and this equation that you got and you're working towards elimination, we can multiply this one by 7 and this one by -5. It'll eliminate the y's. And then when you multiply those things, multiply everything, and you put them together, and you divide this out, we end up with x equaling 7, which does match what we got on this one. Let me go back here. X equals 7. Okay, you do not have to use this method. If you want to use the pure calculator, that's fine, but I wanted to give you another resource just in case, and it sure can't hurt you to know how to do this in the manual way. Depending on what you do in college, you may or may not need to be able to show that. I needed more space, so let's just do this. Okay, so then in order to find another value, you take that 7 and you plug it into one of the equations. It doesn't even matter which one. I'll just pick this one. 7 times 7 plus 5y equals 54. So 49 plus 5y equals 54, and take away 49, so 5y equals 5. That gives you your y equals 1. And then plugging back into any equation that you want to find z. Since this one's showing, I'll just pick this one right here. 4 times 7 minus 1 plus z equals 30. So I have 28 minus 1 plus z equals 30. And so 27 plus z equals 30, subtract 27, z equals 3. Sorry, my mind is going faster than I can write it down nicely. Okay, so your answer is an ordered triple 7, 1, 3. In order like that, 7, 1, 3. Okay, so either way, solving is fine. Okay, just to make a long answer short, you can do that. Okay, let's move on through that. That was one of the trickier things. Solving by factoring. We've done enough factoring that you should be good at it by now. You're looking for factors of the last number that when you add them together, it gives you the middle number. So 9 and 3, we factor it out. X plus 3 equals 0 or x plus 9 equals 0. So x is negative 3 or x is negative 9. The problem that sometimes I notice that some of you are having is just making this and this the answer. Remember, x plus 3 has to equal 0, so it ends up being opposite. So be careful of that. Make sure that if you plug this in, you get a 0. That's the whole point to this. Once again, factors of negative 35, that when you add them together, you get 2. And you can solve by that method very quickly and easily if it's factorable, especially if there's a 1 in the front here. Okay, so solving using the calculator. Sometimes factoring doesn't work, so you need to be able to use the second calc 0 for that. Okay, so we're going to take a look at that. We need to put in y equals, make sure your plots are off. Remember, if the plot was on, you can go up there and just hit enter to take care of that. So I want y equals x squared. You can either use the squared button or the caret 2, plus 5x minus 4. Then we're going to use this calculator. So let's zoom 6 it and get an idea of what it looks like. All right, we knew it would be a parabola. It's hitting in 2 places. We can tell that it's at about negative 6 if we count, and at about 1, but we want the exact answer, so we're going to do second calc, or second trace, which gives you calc. We want to find the 0. Let's go over and find the left one first. I'm going to move this over to the left as quickly as I possibly can. There we go. Because I'm looking for going to the left of the left-hand answer. My cursor goes up here. Here's our first answer. I need my left bound to be to the left of that. And I hit enter. And I move my right arrow until I get past it to the right of the right answer. And I hit enter. You can guess by going close to it and hit enter. And negative 5.70 if I round to the hundredths place, and the direction said round to the hundredths place. There's another one. You have to repeat the process. Second calc 0. So I need to move over close for my left bound. I want to be to the left of the second answer. Okay, here I am. See my cursor. Here's my second answer, and I'm to the left of the second answer. I want to hit enter. And then I need to move to the right of the second answer by continuing to go. And I hit enter again. And then I want to guess, go kind of close to it for my guess, hit enter. And 0.70 if I round to the hundredths place, tenths, hundredths, thousandths. So I want to round right here. The number to the right of it is below 5. So I leave it alone, 5 or above, and you bump it up. Same process for this. It's just a different equation. So you would go in and you would follow that process. Another tool that you have at your disposal is the quadratic formula. Quadratic formula is good if you're needing to find an exact answer. So we look here, it doesn't factor easily. So I want to use negative b plus or minus the square root of b squared minus 4ac all over 2a. A, b, and c. So negative b plus or minus square root b squared minus 4ac, this is not a squared, it's just a 2, all over 2 times a. then systematically go through and simplify. When you get here, look to see if this one factors. Okay, 40 factors into 2 times 2 times 2 times 5. One pair of 2's can come out. So I have 2 square root of 10. Break it up so that it can be reduced. 8 over 6 becomes 4/3. 2 over 6 becomes the square root of 10 over 3. And I will try to make the entry of this into your entry form as painless as possible for that. All right, let's keep moving right along. I know this video is long, but most of you are not watching all of it. Solving by factoring, don't forget that if you need to solve by factoring, you do have to make sure you have a 0 on one side, so you bump this over. Look for your GCF. Once you've had your GCF, you need to factor what's left, and then any one of these 3 factors gets to be 0. So x equals 0, x minus 7 equals 0, which gives you 7, or x plus 6 equals 0, which gives you negative 6. If you have a situation like this, there's a couple things you can do. One of the things that you could do, if you wanted to, you could factor this, but the other thing, because these are both perfect squares, you can just add 64 to both sides, divide by 81, and square root both sides. Remember, when you use a square root to solve a square, you get a plus or minus. You get 2 answers. You square root numerator, square root denominator. Over here, you square both sides. And then you go through and you end up with just one answer. A square will undo a square root. A square root will undo a square, but remember, when you're undoing a square root, you get 2 answers. All right, this one. This one involves recognizing that these numbers can be written as 2 to a power, just like that one. So 64 is really 2 to the 6th. 32 is really 2 to the 5th. Since they're the same base, then the exponents would have to be equal also to make you get the same number. And then you would take this, and all of you know how to solve this problem. Add 3, divide by 5, and get a number. You can get a decimal as long as the decimal ends, or you can get a mixed number if the answer ends like that. All right. Now there's no way you're going to get a common base out of that, so that's where you need to resort to your calculator and using the logarithms. So the calculator does not have all of the bases, if you remember correctly. Okay, it does just have a regular log, which is a log base 10, and it has a natural log. You don't have to worry about the natural logs for this, but if you take the log of both sides, kind of like doing same thing to both sides of an equation like you've done before, you can then use the properties of logarithms to solve it. I'm not getting crazy on giant problems, just these simple type. If you know how to do these two, you're good. So if I take the log of both sides, this exponent can come down around front. You can then divide both sides by log 5, and then it's a matter of calculator only. Log of 7 divided by log of 5. 1.21 rounded to the hundredths place. Okay, this problem is similar, exact same process. Log of both sides, and then divide by log of 6 after you've brought the x down around front, and you get your answer very nicely and cleanly. Okay, so solve and graph. Okay, this takes you way back to Algebra 1 again, really a mix in this, but also we went over it again. So solve it just like it were an equals, and then greater than or equal goes right, less than or equal goes left, put a closed dot if it's an or equal to. It would be an open dot if it wasn't, and I'll have a good elegant way of you showing that, trying not to make it so too difficult. You won't be sending me any pictures. Okay, ors and ands. So same thing, you need to solve each individual piece. An or means both pieces go on the graph just as is. If they run over each other, great. Just whatever they are, put them on the same graph because this is true or this is true. For the and graphs, you have to make sure it makes both of them true. So it has to be bigger than negative 1/7 at the same time it's less than 4. So it's a limited range on those things. Okay. Speaking of range, different meaning of the term. Domain and range. Domain are the x values, as you know, and range are the y values. Simple, easy breezy. When you're trying to use function notation to solve a problem, it's another way of just asking you to plug in the number and then do the math and simplify. This, of course, meaning absolute value, so you turn whatever was in there into a positive. And let's do a little simple calculations. Constant of variation where y varies inversely. Remember, inverse variations multiply these. This is just very recent that we did this. So k equals 2 times 14 because it says the word inversely. And then the equation is y equals 28 over x. It says find y when x equals 10, so you plug that value in and get an answer. Slope of a line, y2 minus y1 over x2 minus x1. You've been doing this for years. Okay? y2 minus y1 over x2 minus x1. Just be real careful of your signs. Equation in slope-intercept form. Okay, you need to first find the slope, which I just talked about. Then you can use your point slope form, y minus y1 equals m times x minus x1. And then simplify by getting y by itself, and that puts it into slope-intercept form, just like you would want it to. And we move right along from there. All right, graphs. You are not going to be doing these type of graphs, but I want you to recognize these major types of graph. Y equals mx plus b gives you a linear graph, so you would be able to recognize this in a matching type of a scenario. Y 3 to the x power equals plus 2. This is an exponential type graph. An exponential type graph, if you remember, was the ones that went up like this in a curve. And we also have to remember, you don't have to remember all of the details. I'm not trying to fool you. Just if you look at these, you'll be able to tell which type of graph. Y equals 1 over x plus 5. This one is an inverse graph. This is what an inverse graph looks like. This one, it's a second power. That makes it a parabola, so this would have this shape to it. Notice that we also, we've got a lot of things going on here in this. We also have this. This is a V-shaped graph, and so you should recognize that. So you're looking for the general shapes to see what these graphs look like. All right, I believe there was actually a mistake on this graph. I believe it should be moved right 4 and up 2 instead of left 4 and up 2. But you're looking for general shape. The squares ones are the parabolas. This is V, and moving right along with these things. All right, factoring. Factoring, we already kind of touched on that for these with a 1 at the beginning. And if you're asked to provide the factored form, nice and easy to type into the answer form, where the factors of this one add up to be this one. Factors of negative 15 that add up to 2, 5 and negative 3. Factors of negative 12. So you do have to put the parentheses in, because remember, these things would need to be able to be multiplied back in order to get that. All right, so x squared minus 25, difference of two squares. Okay, difference of two squares. So 5 and negative 5, 2 and negative 2. 10 and negative 10. Notice they're always equal and opposite, and when you multiply them together, you get that number. If you were to multiply this back out, negative 5x and positive 5x would cancel out. That's why difference of two squares works. All right, on here, 6 and 24, because there's not a 1 here. It's a little more complicated. You have to multiply these two together. Then look for the factors that add up to the middle number. You find that when you get to 9 and negative 16. It's not as simple from here just writing in the answer. You have to break up this middle piece. Once you've broken it up, you factor this part and you factor this part. And then that gives you the matching piece that's multiplied times both the 3x and the negative 8. Same here, 15 and negative 8 get multiplied together. Check your factors until you find the one that gives you a 14 in the middle. Then break it up, factor the front end, factor the back end. 5x minus 2 matches, and it's multiplied times both 4 and 3x. So that's that final answer. When you have complex numbers, it's when you get square roots of negatives. So the nice easy ones are just where you've got perfect squares and a negative. So square root of 16 is 4, imaginaries, and square root of 100 is 10, imaginaries, and just move on from that. When you're simplifying using complex numbers, if you're adding or subtracting, think of that I as just being a variable and go ahead and put them together like terms. Okay, if you have a minus, it's a little bit more because you have to remember to distribute the negative first before putting the like terms together, just like if it was just a regular old binomial. Here, multiply and make sure that you distribute both terms to both terms. But then at the end, realize that I squared will always be a negative 1. So that's the difference between a regular binomial times binomial and the complex numbers. Because at the end, you need to take out the I squared and put in the negative 1. 34 minus 34i is the answer on this. These two numbers do not have to match. They just do in this example. All right. Finding the zeros of the functions. Those are the numbers that make these 0. Okay, 12 makes this one 0, negative 8 makes this one 0, 3 makes this one 0. Remember, the zeros are just the ones, if you plugged in a 0 here, what numbers would go in these? So negative 2 gives you 0, 17 gives you 0, and negative 4 gives you 0. Write a polynomial with the zeros. So in order to do that, you have to write y equals x minus 9. X minus 15, x plus 3, because in that case, those are ones where if you plug them in, you would get zeros. So you're going backwards of the numbers that you're given. So x plus 8, x minus 20, x plus 7, because they're the opposites of those, and that would give you the 0 that you're looking for. Dividing using synthetic division, a nice quick way. Not doing the long division, just synthetic. Use the coefficients of the terms across the top. Remember, you bring it down, you multiply. Don't forget to make this the opposite. Okay, has to do with that whole 0 idea again. So bring down the 1. 1 times negative 5 is negative 5. There's 3. 5 times negative 3 is negative 15, negative 8. Then positive 40 and gives you a 0. X squared plus 3x minus 8. And there's our answer right there. Describe the transformations. Okay, so this one is a parabola. It means it's going right 3 and up 8. This one, if this has the parent, you look at this part, the part with the x to tell left or right. In all of them, you look at the part with the x to tell left or right. And the part that's hanging out by itself after the whole thing would tell you up or down. This one doesn't have an up or down, but it does have a number on the front. And if there's a number on the front end, it tells you you have a stretch or a compression. So this one, compression 1/5, right positive 3, that's a positive 3, and up 8. This one has a stretch of 4 and is right 5, but there's no up or down part. This part has no stretch or compression, but it does have a left 2 and a down 12. And you've been doing great with those. Okay, the inverse. This is y equals 7x minus 12, so switch them and do x equals 7y minus 12. Once you've done that, you need to move things around until you get y alone. So you're adding 12 and dividing by 7. Make sure that you can recognize it in either form. x plus 12 over 7, or 1/7 x plus 12 sevenths. Okay, x plus 4 over 2, 1/2 x minus 2. If you entered something like this, I'd be able to recognize whether you put it in like this or like this. If you choose this one, please put parentheses around your x plus 12 if you were typing it in. X plus 12 divided by 7. Okay, so that you have that. All right, and that's how that's written in. Okay, so simplifying when you have the squared, remember this is where we were looking for groups of 2 or groups of 3, or if you've got 2 square roots, putting them together under one square root symbol first. So square root of 16 is 4. This one, the easy way is to take the exponent divided by the index. 12 divided by 2 is 6. Here, 5 times 5 times 5 is 125. That gives you 5. 18 divided by 3 is 6. And that gives you your new exponent. When you have 2 of them, put them together as one thing, and then do your simplifying. 5 times 100, and then like that. Just be careful when you do this, but these actually simplify very nicely because you don't have to do them in little bits and simplify this and then this. Put them together first, and then that a lot of times saves you time. All right. Wait, is that the same one? Oh, hold on. No, I just went back by accident. Sorry about that. Okay, rationalizing the denominator, that deals with the conjugate of the denominator. So you're doing 8 plus square root 3, 8 plus square root 3. And then distribute carefully for the numerator. The denominator, remember the reason for conjugates is that the middles drop out. So we get 64 minus 3 down there. This one doesn't simplify even beyond that. Same thing, you're always looking for the conjugate of the denominator, putting them together. This one will simplify because divisible by 2 and divisible by 2, you can break this down into 48 over 22 and 14 over 22 and simplify, but just you can't put these things together because this one has a radical and this one does not. So they do have to end up separately. All right, so f of g of 4 and f of g of 2. This one some of you were having some trouble with, so we'll hit this again. Okay, do the thing that's closest first. So g of 4. Use this function. We got a negative 4. Then apply the f function to it. X squared minus 5. Negative 4 squared minus 5. Simplify that so your final answer is 11. Always do the one that's closest to the number first. F of g of 2, we do g of 2 first. Once you get an answer, you plug it into the f function and then simplify it down. So f of g of 2 is 31. Almost done, guys. Growth or decay and the y-intercept. Okay, growth or decay is determined by what is taken to the power. So growth is the ones that are greater than 1 here. Decay are the ones that are less than 1. The y-intercept is the other number that's not taken to the power. All right, and that is it, I think. Nope, wait, sorry, one more. One more important. Okay, so we're not using the continuous compounding formula. We're using the one that has you take how much the original amount times 1 plus the rate as a decimal, 4% as a decimal, and then to the power of how long that took, the t power. So the amount times 1 plus the rate to the t power. Okay, and then this is a matter of put it in the calculator and get a solution. Be careful. We want 5,200 times 1.04 caret 19th power. And that gives you your $10,955.62. 5 and up rounds up. All right, that's it. Okay, so if you're still listening, God bless you, and study well. Praying for you. Have a great rest of your day, great weekend, and a great summer. God bless.